All right, our third and last video in this unsupervised learning clustering section talks about how we analyze clusters. So one of the things we have with k-means clustering is we have to select the number of clusters k for this algorithm to work. We need to do that. And the question is, how do you select that? Sometimes you can visualize this, but again, often with higher dimensional data, it's not that easy. Although sometimes you can use principal component analysis to bring this down into a couple components, which you can then graph to see some clustering. But there are some other techniques, and we're going to look at two: elbow analysis and silhouette analysis. So let's talk about elbow analysis first. So for elbow analysis, what we do is we run our clustering algorithm with a whole bunch of different cluster sizes here. And then we see how well they're clustered. So what we're going to do is sum the squares of all the distances. We do some measurement of how good these clusters are. And so basically we are going to calculate the distance of each data point to its nearest cluster center here. So let me jump back up here. Like in this example where the clustering is pretty good, each of these data points is not very far to its nearest cluster. Where if we only had one cluster, some of these points would be very far from this. And even if we have too many clusters here, let's see if we have, here we might have too many clusters here. And again, it's not so clear here. So we have to have some measurement for how close we are to the cluster center. So we have that measurement on this side, and we just plot that for all the clusters. So if we have this distance measurement for one cluster, it's very high. Everything is going to the one cluster point. If we divide it into two clusters, things are closer to the cluster centers because there's two centers here. And then 3 clusters, 4 clusters, 5 clusters. So hopefully when we're getting up to 4 or 5 clusters, things are getting very close to their cluster centers. So like here we're seeing 5 clusters, and then all the data elements are very close to their cluster centers here possibly. Here. And as we keep adding clusters, we'll do that. Now, there's some diminishing return here. There's a nice quote from Wikipedia. So we're looking for what is called the elbow or the knee of this curve here. So this is a common heuristic in these optimization problems where we want to choose the point of diminishing return. So adding more clusters here does not actually improve our performance. We want this graph, we want a low number on this distance. That means all the clusters are pretty close to their centers here. But as we add more clusters, more Ks here, we don't see much improvement. So when we go from 8 to 9 or 10, very little improvement. So going from 8 clusters to 10 clusters or 14 clusters really doesn't help us at all. But going from 1 to 2 helped us a lot. Going from 2 to 3 helped us a lot. Going from down here. So right around here is where we want to look at our cluster things. You know, maybe 4 or 5 clusters, 3, 4, 5 clusters is where we have our knee of this. And that's what we do want to look for in our cluster analysis for this. So here, this is actually links to the Wikipedia article on this elbow analysis clustering. Then they show, again, a different example this time going up, finding the knee of the curve here and talking about what this knee is a little bit. And then this article here links to this graph, which just talks about, again, a little bit about k-means and then this elbow that we're often looking for as this goes down here. All right. A more detailed analysis is what is called silhouette analysis here. And there's this article on silhouette analysis for k-means clustering. So, and here's a quote from, again, Wikipedia talking about silhouette analysis. So it measures how similar objects are to its own cluster, so cohesion, compared to cluster separation here. We have a silhouette analysis. So again, we're looking at clusters here, and we're doing some measurement for how close they are to their clusters compared to how close they are to other data points in here. So the silhouette ranges for every data point ranges from -1 to +1, where high values indicate objects are well matched to their own clusters and poorly matched to neighborhood clusters here. And again, watching the neighborhood clusters are important because, like, let's say we had, like, this is really a couple clusters. Let's say this clustering is not very good in this. This should probably be one cluster and two clusters. So again, the silhouette analysis, some of these are very close to their own clusters, but they're also very close to another cluster here. So that will give a poor result from silhouette analysis here for this. So that's what we're looking at. Most objects will have a high value, then the cluster configuration is appropriate. So we want a high number for this cluster value. So if many points are low or negative, the clustering configuration may have too many or too few clusters. So how do we graph this out? What we generally do is graph out each data point and calculate its silhouette number for each one. And so again, this is going from 0 to 1, actually negative, but we don't usually get negative values very much here. You'll see some negative values poking up here, and then 1 is the most. And so, like, this is a pretty good cluster. Most of the values are up here pretty high, and it tapers off. There's a couple ones that aren't very good here. This is another pretty good cluster here, and this is another not so bad cluster. Now these two clusters don't look so good. And again, if we look at this example over here, so silhouette analysis will show us this sort of value, calculate these silhouettes. When we run it in Python, we'll also often generate these graphs. And again, this will show an approximation of our data points. And you can kind of see number 1 here. This is a really good cluster over here. It's all very high, all around 0.8 here. And almost all the values are here. Very few of them, like maybe these couple values are getting close to this cluster, but compared to this cluster, but still a pretty strong cluster here. But like these two clusters, 2 and 4, they should probably be one cluster. There's not a great match here. And so if you look at these two, these are bad clusters. Most of their values are low. They only start up at 0.5 and they actually go negative here. So these two clusters are bad clusters. So this would argue that you might want a different number of clusters than this for this. This red line here shows the average silhouette score for the whole thing, and that's often what you can just, besides looking at this graph, you can often just compare the silhouette scores for this stuff. So again, when you're doing cluster analysis, you can run this for different size Ks, and rather than even just looking at the graph, you can just look at the silhouette average silhouette score, and you just want to find the K number of clusters that gives you the highest silhouette score. There. You can then look more in detail to this to see maybe how you might want to combine clusters or stuff like that. But we generally run this. This will take some time, and we want to run this graph on a whole different number of clusters. So this is with 5 clusters, with clusters equal 5. We'll do it with n clusters equals 4, 3, 2, maybe 5, 7, 10. We'll do it for a number of different cluster values here. We'll try to find the best value. So that's our 2 ways of measuring clusters and evaluating the number of clusters, silhouette analysis, and this elbow analysis. Hope you enjoyed this.